That gave us a great overview of the capabilities. I hope nobody else was feeling intimidated. I forgot to tell them that again, that everybody doesn't need to use this. But after talking with Scott a few days ago, I said, well, maybe you can provide a little bit more an actual demonstration of using it. So again, about 10 minutes, Scott, if you want to go ahead and do that. I think we'll hold up questions because he may answer the questions. So yeah, about 10 minutes. Okay, Scott.
Okay.
Thank you.
Yeah. So I'll give you an example. I'm not going to do. I found that it's always a recipe for disaster when you try to do something live with the app online, because I go down rabbit holes. So I'll try to stay out of the rabbit holes. But I want to show you an example based on screenshots to give you a little bit more appreciation for what it's like to run the Watershed multi-year model. Again, this is a single model that is taking 30 years of climate data and pushing it through the model and summarizing it on an average monthly condition for that 30-year record. And remember, we're taking all of these inputs from various data sources that are available across the US. And so previously we were looking at the monitor tab. So in the upper left-hand corner, so if you get this far and you're ready to model, you click on the model tab and you'll see these two options. Again, the site store model, the watershed multi-year model. And clicking the button is all you have to do to make the model run. And how long it takes to run currently, as I said, we're having some delays because of the new data we added. That's particularly apparent for Indiana because you have some really dense stream networks that are different than the rest of the states. But within 30 seconds to 2 minutes, you'll get this screen. And so what you're looking at is the output from the watershed multi-year model. And the first thing you're going to see over here is on the left-hand side, it's going to summarize the sediment, total nitrogen, total phosphorus loads from your watershed. So these are expressed as an average annual load. And down below in the lower left, you're looking at the breakdown of where those loads come from different land use and land covers across your watershed. All right. So there's also a hydrology tab. Let's see. Let's make sure you can see my cursor over here in the upper left. There's a hydrology tab which you can click on, which will show you a similar result, but for water itself. Okay. So the next step here is that there was on the previous slide, we can drill down a little bit deeper. And if you're looking here, view the sub-basin attenuated results. So if you're looking at, for example, a Huck 10, it's a pretty big territory. And what you want to get down to is, well, where really within that is a nitrogen source coming from, right? So you have options to look at nitrogen, phosphorus, and sediment. But the model's going to show you in this color-coded way where those loads are originating from. And so the darker the color here, if you're looking at the scale bar down in the bottom of the screen, the darker the color, the higher the concentration of loads in that stream network. So this is a way to get a little bit finer resolution on where the problem sources might be. If you were looking at a watershed from the perspective of where are the sources that we could tackle if we were going to think about changing land use, this would be a way to start doing that. There's a lot more detail here, ways to look at this data graphically, ways to generate bar charts for this. If you do a little bit more poking around in these menus, you'll discover ways to visualize that data in various ways. So this is where we get into changing the land coverage to develop scenarios. So in the upper right-hand corner of the screen, you see a land cover, you see a conservation practice, and you see a settings tab. Those three tabs are all ways to get behind the model and turn some knobs and change reality in the model so that you can rerun it and evaluate the effect of those conservation practices or BMPs. So here's an example of being able to change the land cover. This would be if you wanted to explore how changing zoning might affect nitrogen, phosphorus, sediment, and water flux from a watershed. You could do that with by changing these values. These are populated from your watershed. So changing these will change what the model sees as reality. And running the model then produces a contrast with the current condition. Some of the different conservation practices that you could implement are things like reduced tillage, buffer strips, riparian forests, no-till agriculture. So this is you can select these and implement those on any proportion of the watershed that you want to model the effect of, okay? And then finally, there's even more functions for those who really want to get down into the weeds and tune this to be very specific to a land use plan or alternative. You can get in there and really start to dial in very customized scenarios and model the results of those. The other, like we're at the end of the workflow here. So in many cases, if this is for a study, if this is for in a case where you want to preserve that output, first of all, you're going to preserve that by creating an account, it's free, and saving your project, and that preserves all of the work you've done. But you can also export that, and you can share this with anyone to make it transparent and to share how you've done that workflow. Finally, there's a lot of material that we have on the web. It's changing frequently as we make updates to the model. So there's lots of help resources. And then for those who are really inclined, we have a very active repository on GitHub where we're providing the updates of exactly what's happening behind the scenes as we introduce new features. There are bug reports that you can file. You can really learn about what's happening in the development side of this tool and use APIs to pull data out of this tool. So there's a quick overview of one half of the modeling side of things on the watershed multi-year model for this.
Okay, well, thanks. And I look forward to following up with you. As I think I wrote last night, using the other model, the runoff one, I can see some uses for education on that one. So that'll be good to follow up. That documentation, I'm glad you pointed out, that really is one of the reasons that I appreciate this model so much, that you keep it very well documented. And finally, I'll follow up too, but the high resolution streams in Indiana are really a problem. I stopped fighting that battle maybe 5 years ago, but they're incorrect, but that's what USGS accepted them. So we should follow up on that because it is a problem. Okay, does anybody have questions for Scott? Like, as you can see, this is not a simple thing, but for R3, if you've done the other things and you're ready to try something new, this is a great opportunity to try it. And I would love to work with you to hear how it goes. Any thoughts or questions?
I have a quick question. Just when we were getting put into these breakout groups, I went and looked up my watershed that I live on in the model, but there's no water quality data. It's a Huck 10 watershed with 2 major water supplies on it, plus multiple wastewater treatment plants and a USGS super gauge in town. So I know the data's out there. So am I doing something wrong to try to find it?
And specifically, you were using the monitor feature to look for those data, right?
I started looking at Analyze just to see what water quality data was out there.
Right. Okay. So let me go back here. You want to look. You want to. There we go. I'm going to share my screen real quick.
I can imagine that there are actually 10-digit watersheds in Indiana that have no monitoring data, but it sounds like yours actually does.
Yeah, I mean, there's a USGS super gauge that was put in 5
Uh-huh.
years ago that's been collecting continuous data, and USGS has been out there monitoring every 2 weeks for the past several years. So, like, I know the data's there.
Okay.
I just can't find it.
Yeah, so again, you're hopefully using this tab. Yes.
Yes, I'm sorry.
Okay, and it's very finicky with keyword. I would suggest the first thing you do is try the word discharge. It is finicky with keywords that it's searching for within those repositories. So start with discharge, and then you're going to have to try various different things like nitrate or nitrogen and some of those things. So experiment with that, but I'm sure you should be able to find it.
Okay, and if not, you guys have a web help form, right? That's how I got in touch with you. So that would be, if you want to provide specifics, Shannon, I bet somebody will get back to you why that's not happening. Thank you for trying it. That's great. Any other questions or thoughts?
I did have a few questions. I use a lot of ArcGIS data and different web map data for phase 1 site inspections, as well as watershed type stuff. And one of my biggest frustrations, I love the models, I love the data being there kind of on demand, but it's only as good as who's inputting the data and where they got it from and things of that sort, which I have found to be problematic as far as getting things updated. Do you, I'm sure you said you have multiple sources that you pull from. Is there a way that you kind of check up on the data, or just what is your QA QC kind of policy for the data that you're using for your model?
First, all of that is really well documented and updated in the documentation. So,
okay.
So definitely go there and read up on the documentation. That's one of the things we do a really good job at, is keeping that documentation detailed. Okay. You might be thinking about the land cover data in particular. I think we're currently showing the 2011 National Land Use Land Cover. We're going to update that. I think it's supposed to be, it's in the pipeline to be done any day now, to update the National Land Cover to the most current available data.
Okay, I did hear you mention the documentation. I was interested in that. I just didn't understand how detailed it was, I suppose. So I'll take a look at that. Thank you.
Yeah, yep.
And poor quality data is pretty much a problem on all our layers, as you know, right? So all that most people do is provide better access to them, but they do have problems. So all the other tools I'll talk about, it's the same problem. Any others? Okay, well, I hope someone will try it, and be sure to, if you could contact me if you decide to try it, because I don't always see them right away. And then I'd love to interact. And Scott, maybe I'll get back to you with how people fare with it if some people actually try it. And yes, Scott, you also said that you could maybe put me in touch with people at the district, stormwater conservation district kind of level, and how they use it. But I'm guessing from what you said that maybe it's especially the analyze mode, that getting the land use, which is fantastic, is probably one of the main reasons we use it. Okay. Good. Well, thank you very much for joining us. I'm going to go ahead to some other tools, so you're welcome to stay on, or as you like, but thanks. And I'll be back in touch. Really appreciate it.
Okay. Thanks a lot. Thanks for the opportunity.
And then I added the sound, so you can see the video either. Well, I guess it's only been about a minute into it. I'll cut that part out of the recording. Sorry about that. All right, so that's what's going on with How's My Waterway. This is the floodplain information. If we zoom into, and first of all, this is right now, right? We see the official floodplains. And so what people in your watershed may want, I mean, first of all, just the floodplains themselves are extremely important to see what is needed. But this also gives access to the official reports, the floodplain, I don't know what a FAR report is. Maybe somebody knows. It's the report that you would need for, selling a house or something like that. It's the official floodplain report. So I don't think there's a lot to say about it. I think it's very self-explanatory. Like all tools built in Esri products, and some of you I'm sure have used them, there's always these three at the top. This one shows the legend, the one with the dots. It shows what each of the things mean. This one allows you to put on or take off the different layers, and then this one gives you more information about them. So the legend is the most important to show. But floodplain information, for those of us who have been around for a while, it used to be difficult to find. You had to go to your, in our county, you had to actually go to where the hard copy information is. You had to go to the courthouse. But now it's extremely accessible. So I think this is absolutely wonderful. At the same time, though, I wanted to mention that there's this other tool that came out from a private foundation either last year or the year before, and it's called floodfactor.com. And they're using a different method. They're actually going beyond the officially recognized floodways to actually run models in a new way and to give you the option of looking at climate change. So as we think about what's going to happen in the future, I think this is really helpful, and it's also really clear. So if I type in a zip code, I type in mine because that's what I know best, then it will bring up a map of the entire zip code, but of course you can zoom in further. So here's West Lafayette. And what it's showing is the actual buildings that are in the various flood risk areas. And you'll see that there are more here. It's casts a broader net than the official DNR floodplain portal, but it's trying to get people to wake up and think about the actual flood level. So they look at what has a 26% chance of being flooded over the next 30 years. That's the 100-year floodplain. And it says it's 7% of all properties in this zip code. So I think they're really trying to wake us up to the fact that flooding is a problem now, and it's getting greater. And I think that all of us as watershed leaders really need to be aware of that method. So I'm not going to show you all the things that they do. There's just a lot of levels. You can, get the depth of flooding as it moves around. It, like most modern web tools these days, it's very easy to move the map around and you see depth of flooding, right? So some of these places would be 3 feet deep. You can choose your, I guess, to have a depth. Obviously you need to have a likelihood. So this is the 500-year flood. A 1% is the 100-year flood. So then these wouldn't be nearly as deep, but you can really dig in and look at the various flooding aspects. So if some of you are interested in flooding and can see a use for that, I would encourage you to choose that for your R3 module, where we're asking you to look at some tools and find out more. Finally, I want to show you some of the other layers that are available in Indiana Map. And because I knew that I would have trouble, just like Scott, doing things live is not usually great, but I made last night this video, and I'm going to share the link to it, but I thought I would just play it the first few minutes, and then we'll take questions or comments. What are your experiences with any of these? And hopefully that's useful. So I'll play about 5 minutes of this. And a map is the layer gallery. You can see the categories here, and they're the same up here. So I'm going to click on the first one, environment, and you can click on any of these subcategories, but I found it's easier to just click explore all, and then we get all of them with fewer clicks. So for any of them, I want to give an example of the confined feeding operation. You can click on the preview and find out quite a bit about this. There's a description. This gives all the confined feeding operations, which are the regulated livestock facilities in Indiana. And you can get a preview of what they are. Clicking on the legend easily shows the categories. So the main ones are the smaller confined feeding operations and the larger confined animal feeding operations, or CAFOs. In the metadata, we can also find out more about what are the questions we can ask of this. We can either click on the metadata, and this is probably not very meaningful to you unless you already know GIS. It's a standard format for all the information about it. But a slightly easier way is just to click on any of the dots, and now we'll see in a table the information that's available. So for each of them, We see whether it's a CAFO or a CFO, and we see the number of animals. So this one has 4,920 sows. So that means that same information would be available for all the others. And now we'll browse through some others. One thing I want to mention is that some of the layers are very old. For example, this one, Agricultural Census 1997, that is out of date. There's been 3 additional ag census since then. So it just means the Indiana Geological and Water Survey has not chosen to keep that layer up, but they didn't delete the one that was there. So don't assume that just because they're here, they're terribly recent. The same is for the crops. They used to download them every year, but the last time they did that is 2016. So there are other places to find the cropland layer that are more recent. The land cover also is not the most recent, so there are national databases that you can get it from, but it's certainly good enough. Another one I think is interesting is this managed lands. This is a brand new layer, 2020, and it's quite interesting. It's all the land that's managed by federal agencies or cities or counties. So for each of these, it shows the park and something about that place. So I think there's a lot of information that could be helpful if you're looking for parks or managed land. You can see some of the monitoring data. This bacterial layer, don't do anything with it because it's from 1994. That's way too old. It's especially good to look at the ones that are fairly new. So I thought, for example, the brownfields layer is quite interesting. This shows sites where there was an environmental problem, so there's a piece of real estate that's not well used because of that. If we click on legend, we see that there's active and inactive sites, and if we click on one of them, we can see what further information we get. So there's something about how it's being followed up as well as who owns it. Okay, I'm going to stop there. But as I got doing this last night, you could hear my voice editing because I do quick editing when I make a mistake. So then but it's put together now. You don't have to watch the mistakes. That's why it's the advantage of recording versus doing it live. Because, a lot of things don't show up as I think they're going to show up. But I just went through a lot of them and picked out what I thought would be interesting for watershed managers that many people will not know about. Some you know, but I think there are many that you won't know because there are many that I didn't know were there. So I hope that that's useful to you, and I'll post that link. So now I want to ask, just in the last few minutes, of what's your experience? Are there any tools that you want to share, or do you want to ask me about any of these that I have shared? Because what we're going to do for the next assignment is have you use a couple of them.
I think you already touched on my frustration of out-of-date data or incomplete data, multiple sources for more updated data. That's my biggest frustration, is going between USGS, EPA, IDEM. And, a lot of the sites say, we pull from all these sources to have everything you need, but they don't. So I'm hoping that watershed tool that Scott was talking about is maybe our new hope, our next hope.
Yeah, well, you'll see. But one of the things I like about it is that, I've filled out their form and they respond. So I think it's good to only use a tool that somebody is looking at. And I figure they need feedback, right? They don't know what data are missing or something like that unless they hear from users. So I always assume that a good developer wants to hear about problems from users. So even if they don't have a formal beta testing. So I would certainly encourage you to get in touch with them.
And it's not like I don't understand that there's all those moving parts to it and so many people who are responsible for providing accuracy, and that can be very hard to deal with. So I do understand that, but it's still a frustration.
It's a huge frustration. And you do wonder in the water data, why can't we do better? So, people are putting resources into it, but it's been such a massive problem for so long. I think that that's part of it, that EPA doesn't really collect the data. They're getting data from states for the most part through many different programs.
Volunteers.
Yeah, any volunteers, even more so. There's more problems there. But even the states, and for many years, for example, IDEM didn't provide most of their data to EPA. So then EPA just had these scattered things that weren't the major data from Indiana. So there's a big state problem as well as the federal agencies putting together. My experience with USGS has always been very positive, though, because they're the ones who collect it themselves. They keep it up to date. They invest in information tools. Is that your experience?
Yeah, if I can get it from USGS, that is my preference. USGS and the EPA, but again, EPA pulls from states. But USGS is my preferred source. There are things I can't find there, so that can be frustrating.
And we hope Shannon can find her super gauge station, because that's certainly very valuable. So it's good. Thank you for bringing up these concerns. Does anybody else want to say anything quick? We've got 46 seconds.
I have two tools that I've used. I do quite a bit of GIS mapping, and I've become reliant on some of Esri's living atlas layers. So for example, they're usually the quickest to get like the latest national land cover data up. So they have all that up to 2016 at this point, which we haven't seen in some of these other tools. And then I've also been using, FEMA has a risk map project. I know it's done for the St. Joe River Basin. I'm not sure about others. That includes a lot of the stuff, more high resolution data, like similar to flood factor. So those are two tools that I've used.
Thank you. The problem with the Okay, we waited till the end, so everybody's back now, and thank you. So in my group, we were having a good discussion about the problem with the underlying data, that these tools are very cool now, but the data is still not all we would like. So that's something to be aware of, and I have a video that I'm going to put a link. I want to make the rest of you at least aware of it, that I looked through all the data layers in Indiana Map and sort of comment on ones, pulled out the ones that I think are most important. But as I look through them again, and you'll all see this, there are many data layers that are out of date. So you just have to ignore them. What it means is the folks at the Indiana Geological and Water Survey have not taken the time to take out the old ones. They add new ones, and probably they should take out some old ones. So my first thought was, I'm going to make a list and send it to them, which I could do. But then I thought, well, just make it sure